Hello. So, this video we are going to be introducing some parts about factoring. So, in the coming videos, assignments, and all kinds of things, we're going to be covering all kinds of different techniques for factoring polynomials. But a lot of these techniques are sort of dependent on certain forms and certain situations, and it turns out that there's some, let's say, meta-functioning stuff going on here that we can do for factoring as well, to turn one form into another form. So these are the kinds of things that we're going to talk about in this video. So as a starting spot, quadratic functions. So quadratic functions are sort of the basic factoring target that we might be interested in. In fact, factoring quadratic functions and how to factor quadratic functions was something that even like ancient Babylonians were figuring out way back many thousands of years ago. So this is one of those things that sort of a nice starting spot. Now, the quadratic function, right, has this sort of particular way of writing this form, even though it's not quite the standard polynomial form we're used to, right, the ax squared plus bx plus c, no subscripts needed. As an example, right, we have this 3x squared plus 2x minus 5. So it turns out, because we've been thinking about these things for thousands and thousands of years, we have all kinds of tools that are targeted specifically toward quadratics that may not work toward most other things. But because math people are kind of crazy, we took a look at those and realized that really it's not the fact that it's a quadratic. It's not that it's ax squared plus bx plus c that's important. It's that it has a quadratic form, right? So form. So that's one of the things that we want to sort of learn to recognize that we're going to talk about in this video. So what is a quadratic form? Well, this is an example of a quadratic form. So quadratic form is something that if we can sort of do a clever substitution, it becomes a quadratic, maybe with a different variable. So to see what we mean, let u be x cubed, meaning I'm just going to define u to be x to the third power. In particular, right, since we're looking at quadratic-y things, I'm going to also look at what u squared is. So if I look at u squared, that's x to the third squared, which is just x to the sixth. But notice that that means u squared is x to the sixth. That's what this thing is, right? 5x to the sixth. And u is x to the third, what this thing is, right? 3x to the third. And so if I substitute those out, I get 5u squared plus 3u minus 14. That's a quadratic, right? In particular, that is a quadratic in terms of u. That's what we would say. So this thing is now sort of susceptible to all of those quadratic function methods now that we have it in terms of u rather than x. And this is what we sort of mean with quadratic form. So we've seen an example, but let's sort of dive in a little bit more clearly what that means. So if we have a function of this form, right, like ax to some power, bx to some power, and c, where that first power is twice as big as that second power. That's what we mean by quadratic form, okay? So in particular, quadratic form is a trinomial. I'm going to put that in quotes because really all we care about is the leading term. The second and third term, they could have coefficient 0, so they may or may not be there. But we will probably end up sort of putting them back, even if with a coefficient of 0, to force it to be a trinomial. Again, we'll see what I mean by that in a second. The important takeaway, though, is that this sort of relationship of x terms and powers is what we really want to zero in on. So we have three terms. One of them has got to be a constant, no power of x, or no positive power of x. So two of them have a positive power of x. One of those powers is twice the other one, okay? So when we look at our original, right, looking at this thing, we had 5x to the sixth, 3x cubed minus 14. This thing had our three terms, right? So it's a trinomial. It made sure that we had two terms that had a power of x, right? The third one was just a constant. And those two powers, one of them, 6, was twice the other, 3, right? 2 times 3 is 6. I know, crazy math we're doing. So that's how we can sort of recognize a quadratic form. All right. Now, how about like going through some examples, recognizing if they are or aren't? So here we have a trinomial, right? So it's three terms. We have that two of them have x, but we don't have the right power, right? So if we have 15 and 10 as our power, 15 is not 2 times 10, this thing, not a quadratic form, right? So I had the first two parts, not the third part. Here, this thing is a quadratic form, but we said, wait, we need a trinomial, right? So we need something that has three terms, two of them have positive power of x, one of them is a constant, and the two powers of x, one is that power is twice the other. But we can sort of inject the third term here to make it work. In particular, we can write this as that 2x to the 10th plus 0x to the 5th minus 1. And now we have the three terms, right? Two of them have the power of x, and one of those powers, 10, is twice the other. So we can sort of inject this zero coefficient term, 0x to the 5th, which is just 0, but we can sort of put it in there, that's what I was saying earlier, in order to make it fit this quadratic form, okay? If we look at this next one, again, this one is a quadratic form, right? Because again, trinomial, three terms, one's constant, two has powers of x, one of them, 8, is twice the power of the other, 4, okay? And this last one, not a quadratic form, right? We have three terms. This 6 is indeed twice the other one, 3, but this third term is not constant. It's also a power of x, so that is not a quadratic form, okay? So quadratic forms are one of those things that are very useful because we have all kinds of tools that work for factoring quadratics specifically. We're talking like quadratic formula, we have completing the square, we have factor coefficients, we have AC method, we have all of these different things that only sort of work when we're dealing with the quadratic form, with a quadratic equation. But really, they all work on quadratic forms, which is why we want to be able to recognize something that isn't a quadratic but can sort of be made a quadratic, okay? Now, the other big thing when it comes to factoring is the idea of factoring versus fully factoring. And this is one of those things where a problem might say, like, fully factor the following polynomial, like our problem here, right? Now, looking at this problem, we haven't actually covered various factoring techniques, so I'm going to factor part of this. Don't worry if you don't know what I'm talking about. We haven't got there yet, but this is by way of example. So the one we have here, this 4 terms, it turns out we can factor this by grouping, which we would do as the step, right? The group them together, factor out common terms, factor out the common x plus 3, and we get something that looks like this. Now, at this step, I have factored it, but I have not necessarily fully factored it, okay? So here, a good rule of thumb, any degree 1 term is done, can't be factored anymore. So in particular, that x plus 3, I know that thing is fully factored, that part is fully factored. Degree 2 terms, those need to be checked. They might be fully factored, they might not be fully factored. Or another way of saying that is they might be factorable, they might not be factorable. So here, this x squared minus 4, it's sort of unclear because it's degree 2 whether it could be factored or not, and it turns out it can. This is a difference of squares. Again, this is stuff that we're going to sort of cover later on. This is just by way of demonstrating that you can factor something without having it fully factored. Last but not least, a good rule of thumb, anything that's degree 3 or higher, always factorable. So if you have a degree 1, you're good with that one, you don't have to worry about it. If you have a degree 2, that you have to check. If you have degree of 3 or more, you don't have to check, you know that it needs to continue going to get factored. So if I want to then fully factor this function, right, I want fully factored, not just factored, then I have to factor that x squared minus 4, and that gets me, right, I can factor that into x minus 2 and x plus 2. That'll get me a fully factored form, okay? All right, so what do we do? Well, we talked about factoring as a general thing and two sort of very common parts that we want to sort of watch out for in relation to factoring in the future. So the first one was that quadratic form, right? We have lots of tools for quadratics, and so recognizing quadratic forms, which are things that aren't quadratics but can be made to look like quadratics with a sort of suitable substitution, is very useful because then we can use all of those tools that only work on quadratics. The other thing is the factor versus fully factor, right? We could factor something using a tool, but end up with something that is still factorable. And in fact, that's usually the case. So if a problem says fully factor, blah, 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 then you actually have to go through and make sure that after each time you have done a factoring step, the resulting pieces, whether or not they are factorable, and continue factoring if they are, okay? The actual techniques is something we're going to cover sort of next, but this is, again, stuff to keep in mind as we're going through techniques, okay? So that is that.